Ethernet is the most popular network architecture. Ethernet is generally easier to install and use and is less expensive than other network architectures. All Ethernet standards use the hardware address of the NIC to address packets. Ethernet is divided into three categories based on transmission, speed, and media. There are four major implementations of 10 Mbps Ethernet. The 10-base-5 Ethernet using thicknet coaxial cable, 10-base-2 Ethernet using thicknet coaxial cable, 10-base-T Ethernet over unshielded twisted pair or UTP cable, and 10-base-F Ethernet over fiber optic cable. 10-base-T Ethernet usually uses unshielded twisted pair or UTP cable, but also can transmit with shielded twisted pair or STP cable. Each computer is an end node on a cable segment, which eases troubleshooting because any cable failure affects only one computer. A 10-base-T network, a star topology in which each computer is attached to a repeater. The 5-4-3 rule is somewhat modified for 10-base-T networks. 10-base-F. So the IEEE specification for running Ethernet over fiber optic cable is 10-base-F and is generally divided into three subcategories. 10-base-FL is used to link computers in a LAN environment. 10-base-FP is used to link computer using passive hubs rather than repeaters, and 10-base-FB uses fiber optic cable as a backbone between hubs. Each of these 10-base-F implementation uses a star topology. 100 Mbps IEEE standards. So the most widely accepted Ethernet standard today is 100-base-T, which is also called Fast Ethernet. High speeds make this technology well suited for applications such as video, CAD or computer-aided design, CAM, computer-aided manufacturing, and imaging. 100-base-T is also called as Fast Ethernet, is an extension of the 10-base-T standard. The 100-base-T standard has three subcategories that define cable types. So the first one is 100-base-T4, means 4-pair category 3 or higher UTP. The second one is 100-base-TX or 2-pair category 5 or higher UTP. The last one is the 100-base-FX, which means 2 standard fiber optic cable. There are two types of 100-base-T hubs. The first, the Class 1 and the Class 2. The Class 1 hubs may have only one hub between communicating devices, whereas Class 2 hubs may have a maximum of 2 hubs between devices. Gigabit Ethernet and 1 Gbps IEEE 802.3z standards. So collectively, the IEEE identifies various Gigabit Ethernet standards under the generally heading 1000-base-X. Two separate extensions to the 802.3 specification cover 1000-base-X and 1000-base-T. 802.3z/1998 covers 1000-base-X specifications, including the L longer wavelength, laser, S short wavelength, and C the copper jumper cables. 802.3AB/1999 covers 1000-base-T specification, which requires 4 pairs of 100 ohm category 5 cable or better. Doing the duplexing. Most Gigabit Ethernet implementations work in full duplex mode. Remember that the two interconnections between a sender and receiver are required when fiber optic media are in use. Two connections make it possible for both parties to send and receive. Because this capability is inherent in the medium, it makes sense to use full duplex communication with such equipment, so both parties can send and receive data at the same time. 1000-base-LX uses fiber optic media. The L stands for long wavelength, the kind of laser that used to send signals across the medium. 1000-base-SX uses fiber optic media, and the S stands for short wavelength. 1000-base-CX uses specially shielded, balanced copper jumper cables. The C stands for cable, the kind of electrical signaling used. They are used primarily in wiring closets or equipment racks. 1000 base T. So a 1000 base T employs special equipment called high bridge and canceller. This is to combine multiple signals and to cancel interference to support full duplex transmission over a single pair of wires. Unlike 10 base T and 100 base T Ethernet, 1000 base T Ethernet does not dedicate a wire pair to transmitting or receiving. Each wire pair is capable of both transmitting and receiving data simultaneously, thereby providing the 1000 Mbps data rate in both half duplex and full duplex modes. 10 Gbps IEEE 802.3EA standards. So the primary use of 10 GB Ethernet is as the network backbone, interconnecting servers and network segments that are running 100 Mbps and 1000 Mbps Ethernet technologies. As this technology matures, a number of implementations have been and are being developed. So these are broken into two basic groups, which are the 10G base R for LAN applications and 10G base W for WAN applications. Both groups have short range, long range, and extended range implementation, which include the following: the 10G base SR, 10G base LR, 10G base ER, 10G base SW, 10G base LW, and the 10G base EW. Ethernet frame types. So Ethernet supports 4 frame types, each of which is unique and does not work with the others. For communication to take place between any two Ethernet devices, their frame type setting must match. So Ethernet 802.3 is generally used by IPX/SPX on novel network 2.x and 3.x networks. Ethernet 802.2 is a default frame type used by IPX/SPX on novel network 3.12 and 4.x networks. So this is also the native frame type supported by default when Microsoft NWLink is installed. So the third one is Ethernet Snap, is used in EtherTalk and mainframe environments. And the last one is Ethernet 2 is used by TCP/IP. So all Ethernet frame type supports a packet size between 64 and 1518 bytes and can be used by all network architectures mentioned above. Ethernet 802.3, or sometimes called as Ethernet Raw. So the Ethernet 802.3 frame type was developed before completion of the IEEE 802.3 specification. Generally, Ethernet 802.3 occurs only on networks that use Novell's network 2.x and 3.x. Ethernet 802.2. So Ethernet 802.2 frames completely comply 802.3 standards. Because Novell had already decided to use the term Ethernet 802.3 to describe Ethernet Raw, it is generally accepted that Ethernet 802.2 means fully 802.3 and 802.2 compliant Ethernet frame. Ethernet 802.2 contain similar fields to 802.3 with 3 additional LLC fields. Ethernet Snap. Ethernet Snap, or Subnetwork Address Protocol, is generally used on the AppleTalk Phase 2 networks. It contains enhancements to the 802.2 frame, including a protocol type field, which indicates the network protocol used in the data portion of the frame. Ethernet 2. Ethernet 2 frames are used in TCP/IP networks. Ethernet 2 differs only slightly from 802.3 frames. So rather than using a separate SFD or start frame delimiter, the preamble includes the data. So the type field replaces the length field and is used much the same it is used in Ethernet Snap to identify which network protocol is in data section of the frame. Segmentation. So greater numbers of computers and increased traffic bog down most network implementations. One way to ease this problem is by segmenting the network into manageable pieces. By inserting a switch or router between network segments, you direct traffic more efficiently to its destination and reduce traffic on each segment. Wireless Ethernet, the IEEE 802.11b, A, and G. So the 802.11b AG technologies uses an access point or AP that serve as the center of a star topology network. Workstations equipped with wireless NICs sends packets to the AP, which then sends the packets to the destination workstation. 802.11b AG specify a CSMA CA access method in which an acknowledgement is required for every packet sent. With this requirement, if a collision occurs, the sending station knows the packet did not arrive safely because there is no acknowledgement. Token ring. So the token ring network architecture provides user with fast, reliable transport. So it uses a simple wiring structure with twisted pair cable that connects the computer to the network through an outlet in the wall. Most of the wiring is in central location. By using the token passing channel access method, token ring networks ensures that all computers get equal time on the network. A computer receives a token from its nearest active upstream neighbor or NAUN. If the token is not in use at that time, no nearby computer is sending data, and the computer has data to send, it attaches its data to the token and sends it to the nearest active downstream neighbor or NADN. One of the unique aspects of the token ring network architecture is its capability to automatically isolate faults by using a process called beaconing. The first computer powered on a token ring network is assigned the responsibility of ensuring that data can travel along the ring. This computer, the active monitor, manages the beaconing process, so all other computers on the network are standby monitors. Beaconing allows some level of automatic fault tolerance in the token ring network and something many other networks architectures lack. In a token ring network, a hub can be referred to as Multi-Station Access Unit or MAU or MSAU, or Smart Multi-Station Access Unit or SMAU. IBM's implementation of token ring is the most popular adaptation of the IEEE 802.5 standard. A typical IBM token ring hub, such as the 8228 MSUA, has 10 connections, 8 of which can be used for connecting computers. The ring out or RO port on one hub connects to the ring in or RI port on the next hub, and so on to form a ring in this manner. IBM defined a comprehensive cabling system that specified cable types, connectors, and all other components required for computer networking. This cabling system breaks cables into different types based on the American Wire Gauge or AWG standards that specify wire diameters. So on the right side is the table of IBM or token ring cabling from type 1 to type 9. AppleTalk environment. So AppleTalk is a simple, easy to implement network architecture designed for use in Apple Macintosh computers. As a introduction, AppleTalk referred to the networking protocols and the hardware used to connect computers. In 1989, Apple changed AppleTalk's definition to refer the overall architecture of the network and added the term local talk to refer the cabling system. Unlike Ethernet and token ring, which use the address of the NIC, AppleTalk applies a dynamic scheme to determine the address of a device. When Apple introduced AppleTalk Phase 2 in 1989, it introduced EtherTalk and TokenTalk, which allows AppleTalk protocols to operate over Ethernet and token ring networks, respectively. Local Talk. So Local Talk network architecture uses STP in a bus topology to allow users to share peripherals and data in a small home or office environment. The Local Talk connector consists of 3 connectors, one to the computer and the other 2 that join the devices. Local Talk uses the CSMA-CA channel access method. This method of channel access avoids more collisions. EtherTalk and TokenTalk. So EtherTalk is the AppleTalk protocol running over a 10 Mbps IEEE 802.3 Ethernet network. TokenTalk is principally the same thing, the AppleTalk protocol running over a 4 or 16 Mbps IEEE 802.5 token ring network. Both implementations require that different NIC be used on the computer. Such NIC include all drivers and protocols required to run EtherTalk and TokenTalk. Since 1996, Apple Computer has offered systems with built-in Ethernet interfaces or with options to add Ethernet or Token Ring to its systems at a low cost. The Fiber Distributed Data Interface, or FDDI, uses the token passing channel access method while also using dual counter rotating rings for redundancy. A FDDI network has no hubs. Devices generally connect directly to each other. However, devices called concentrators can serve as a central connection point for a building or individual sites in a campus setting. FDDI uses two physical rings operating in different directions to avoid cable problems. In an FDDI network, all data transmission occurs along the primary ring, while a second ring circumvents a cable break. An FDDI uses two types of NIC. The first one is Dual Attachment Station, or DAS, and Single Attachment Station, which is SAS. DAS attached to both rings are intended for use in servers, concentrators, and other devices that require full reliability. SAS connected to only one ring are intended for individual workstations that are attached to concentrators. Broadband technology. So broadband systems uses analog techniques to encode information across a continuous range of values, rather than using binary zeros and ones that characterize digital in a baseband environment. Broadband signals move across the medium in the form of continuous electromagnetic waves or optical waves, rather than in discrete pulses. On broadband systems, signals flow on one way only, so two channels are necessary for computers to send and receive data. The official standard governing cable modem operation is called Data over Cable Service Interface Specification, or DOCSIS. Cable modem networks share some properties of traditional 10-base-2 Ethernet. It is a shared media bus topology network at the point where the data is delivered to a home. Digital Subscriber Line, or DSL. So it is a broadband technology that uses existing phone lines to carry voice and data simultaneously. There are many flavors of DSL available. The prominent one for home internet access is asymmetric DSL, or ADSL. ADSL is so named because the download and upload speeds differ significantly, so the data rates are not symmetrical. Broadcast technologies are one-way transmissions. These systems work on the principle that most traffic a user generates is to receive file, text, and graphics. So a user taking advantage of satellite service connects to a service provider through a regular modem. Asynchronous Transfer Mode, or ATM. This is a high-speed network technology designed for both LAN and WAN use. So ATM uses connection-oriented switches to permit senders and receivers to communicate over a network. A dedicated circuit, an ongoing link between two end systems, must be set up before communications between those systems can begin. ATMs use a fixed-length cells enable it to work at extremely high speeds because no single transmission is ever larger or smaller than the required cell size. ATM and SONET signaling rates. So ATM and SONET, or Synchronous Optical Network, represent state-of-the-art, all-digital, high-bandwidth communications designed to mix and match data, voice, and all kinds of time-sensitive information through a single high-capacity networking technology. The various signaling rates associated with SONET are the same as those associated with ATM. The attached table are the optical carrier signaling from OC1 to OC3072. High Performance Parallel Interface, or HIPI. So HIPI is a high-speed communication interface originally developed to serve supercomputers and high-load workstations. Serial HIPI is a fiber optic version of the original HIPI, which uses a series of point-to-point optical links to provide network bandwidth up to 800 Mbps. So HIPI and GSM are considered as exotic networking products and are not frequently found in typical corporate networks.